Hello everyone. How are you all? I hope you all are doing very good. See children, physics is never a difficult subject for a student who is interested, provided he or she has a clear and strong physics teacher. So here I am Mr. Dharanidhar, your favorite physics teacher in your favorite YouTube channel Bhautics. So today I brought you one more question that was asked in a previous year board examination, asked for 5 marks in the year 2014, question paper set number 31/4/1, data based question. The question goes like this: they have given a set of values that are recorded for convex lens. First question here is, without calculation find the focal length of the lens and justify. We should not calculate anything. By looking at the values itself, we have to say what is the focal length of the convex lens. So remember that when object distance become equal to image distance, then object will be placed at 2f1. So 2f1 is equal to 50 centimeters. So f1 will be is equal to 25 centimeters. That is what we wrote here. Focal length of lens is 25 centimeters. We know that object distance and image distance will be same when object placed at 2f1. So from tabular column we can say 2f1 is equal to 50 centimeters. So the focal length is 25 centimeters. That is what. Next. Which reading is incorrect? Draw a diagram for this position. From this, which reading is incorrect? So you look at the sixth reading, object distance is 15 centimeters. Object distance is 15 centimeters means 15 is less than 25. When object distance is less than 25 centimeters, image distance also should be negative. So here they gave positive. So this reading will be incorrect. Sixth reading is incorrect because of the object distance is less than focal length. Image distance also should be negative. They asked you to draw the ray diagram also. We'll draw the ray diagram soon, now itself. But let me answer the one more question they asked. They asked to find the magnification value for u is equal to minus 30 reading. So what is the formula? This is convex lens. In lens, magnification formula is m is equal to v divided by u. We have to find out m, which implies m is equal to v. U is equal to minus 30. Where is u is equal to minus 30? Here. V is equal to plus 150. So plus 150, 1 second, m is equal to plus 150 divided by u. U is minus 30. So which implies m is equal to minus 5. Now one more question is remaining. We need to draw the ray diagram. For which case? For this case, when object distance is less than focal length. So let us draw the ray diagram perfectly with measurements, right? So first, to draw the convex lens, take a straight line of length 12 centimeters. With the measurements, if you draw, you will get the ray diagram perfectly. Draw a straight line of 12 centimeters. Mark the points at 3 centimeters, 6 centimeters and 9 centimeters also. This middle point you name as optical center. Right side first point as f2, next point as 2f2. Left side first point as f1, next point as 2f1. So we have to draw a convex lens, correct? To draw a convex lens, take the compass and take the radius of curvature as 6.2 centimeters. See, 6.2 centimeters. 6.2. Why 6.2 only? If you take 6.2 itself, then only you will get a very good ray diagram. 6.2 centimeters. 2f1 as center, draw an arc. 2f1 and 2f2 both taking as centers, draw an arc and close the arc. Now erase the extra part so that the diagram will look good. So now draw one more line here at the center from optical center. This line is very important. This line plays a major role. Why? Because the light rays will change the direction from that line only. Okay, I am drawing a bit faster. So where should be object placed? Object should be placed in between optical center and f1. I will take an object here around 1.5 centimeters, right? So we need two light rays to pass. One light ray I will take parallel to principal axis until this middle line is there. See, until that line light ray should come straight. After that line light ray should pass through focus. Arrow marks are very important. So this is one arrow mark and this is another arrow mark. One more light ray we want. One more light ray I'll take through the optical center. See, this point and this point should be coinciding. Incident light ray and refracted light ray. These arrow marks are very important. So these two are the refracted light rays and they are not meeting anywhere. We want the point of intersection. So what I'll do, I'll extend these light rays back like this. And this light ray also. They both met at this point. So image is also formed on the same side of the lens. Image is virtual, this is object and this is image. Image is also formed on the same side of the lens. Image is virtual and erect and magnified. Thank you. Thank you so much. If you are interested to join our online physics classes, you can contact us.